In this problem, we're going to find the equivalent capacitance CT for this network below, and we've got capacitors, and remember capacitors are different from resistors. They're like conductances. Capacitors in series combine like resistors in parallel, and capacitors in parallel combine like resistors in series. So if we start off, we've got these three capacitors in series, and so their equivalent capacitance, we could say, okay, 1 over C series is 1 over 6 microfarads plus 1 over 6 microfarads plus 1 over 6 microfarads, which is 1 over 2 microfarads. So then C series is 2 microfarads. So now let's redraw the circuit with that combination where we've completed that. We've combined those down. So now we've got 2 microfarads here, 2 microfarads. This is still 4 microfarads, 8 microfarads, 10 microfarads, 5 microfarads, 3 microfarads. This is 6 microfarads. So there's our circuit now. These two are non-parallel for 4 microfarads. So remember, we have capacitors in parallel. We add the capacitances just like resistors in series. So now let's redraw the circuit. Okay, now these two are going to be in series, and if you combine them, that's going to be 2 microfarads. Okay, so now let's redraw the circuit again. Now these two are in parallel. Equivalent capacitance of 10 microfarads. So now we'll combine those and we'll redraw the circuit. And so now our circuit has been reduced to this. So now these are in series, and if you combine them, you're going to get 5 microfarads. So now again, let's redraw the circuit. Okay, Okay, so there's our circuit. Now these are in parallel. This is going to be 10 microfarads. The capacitors in parallel, we add the capacitances. So now our circuit has been reduced to this. So now 1 over CT, all the capacitors in series, 1 over 3 microfarads plus 1 over 10 microfarads plus 1 over 6 microfarads, and that's 3 over 5 microfarads. So CT is 5/3 of a microfarad, and that's 1.6667 microfarads.